Alright, so we jump right into this one. We are doing the derivative of this function, which is question number 11, section 3.4. So, jumping into it, we have to figure out what the question is asking for. And basically, they want you to recognize it's a hidden chain rule again, just like question 9 was. In this case, you could solve the problem using the quotient rule, and it would work, but you'd end up having to do a lot of simplifying at the end. So instead, we make this new chain rule. Now, we've got to use one simple little trick from grade 11 or so algebra, which is that you can have 1 over x squared, and you can move it to the top by negating the exponent. So if you look in the left versus the right, what's changed is that 2 has gone from positive to negative as it's moved up. So we can move a power from the bottom to top just by negating whatever the power is. So the cool part is this works even if it's not a 1 on top, if it's a trig function or the bottom's already negative. So to give you an example, of 3 over x cubed, if we want to move that x cubed to the top, we make it 3x to the negative 3 power. And with that sine x over x to the power of negative 4, if we want to move that x to negative 4 to the top, we have to negate that power. So if it's already minus 4, how do we flip the sign? Well, we make it a positive 4 and we move it up top. So it becomes x to the 4 times sine x. I just left that positive in there just to basically show you guys really clearly that we're changing the sign as it goes from top to bottom. And so in our case, in our question, we have 1 over 2t plus 1 all squared. So we can move that to the top by just making that 2t plus 1 all squared into 2t plus 1 all raised to the power of negative 2. And that's the trick. And so now, if we just pay careful attention to the brackets, inside the brackets there's a t, which should be a giant red flag. The chain rule is going to be necessary. Anytime you see those brackets and you see it raised to a power, that's a sign you're going to have to use the chain rule. Alright, so to get started, to use the chain rule I like to use the phrase the outside derived with the inside left alone multiplied by the derivative of the inside. So to start, we're going to do the outside. And so this is just a power rule. So you basically put the old power in front. So that minus 2 is going to come to the front. And then we're going to subtract write the inside all by itself, left alone again, and subtract the power by 1. So I've done this here in this step. So in the first step, I'm just taking that negative 2 and I'm putting it in front. And I'm subtracting it by 1. And I just wrote the inside left alone. And now I'm multiplying it by the derivative of the inside because of the chain rule. So simplifying that a little bit, we had negative 2 minus 1 becomes negative 3 for the exponent. And the derivative of 2t plus 1, that's just 2. And now we can simplify it a little bit more because we have negative 2 in front multiplied by 2. Negative 2 times 2 is, of course, negative 4. So, and I've just rewritten everything up again. Now, depending on how your professor likes it, some professors are like, hey, I don't want any negatives in my exponents. So, using the same trick in reverse, we can move it back on underneath just by changing that negative 3 to a positive 3. Anytime you go up or down, beneath or above that little quotient line, you just have to flip the sign. Yeah. And so that's how to solve this problem. If you guys have any more problems, even from another textbook, feel free to reach out and I'll do my best to solve for you guys. And yeah, have a great day. Oh, and there should be a subscribe button somewhere and a playlist with more videos over there. Thanks, guys.